Hello, this is Howard Zhang, and I'm prepared for the homework 1 of EL 6303 for Elsa Urquip. And my solution for the first problem is this. So this P A union B given say is exactly the P A union B and intersect C over PC. This is a probability ratio, and both of them are greater than 0. So this one is greater than 0. And so the next thing is P A union B union C over PC. Actually, this is a bigger event and this is a smaller event. So this ratio is bigger or equal to 1. So when A union B is empty, then this is 1. In other case, if A union B will happen, the probability of A union B is greater than 0, then this one will be greater than 0 strictly. So we move this to this direction, and we will get this that 1 minus this one is less than 0. So this one is greater than 0, and this equation is less or equal to 0. So we can use 0 as intermediate and get this equation, this ratio is greater than this one. And so we proved the first problem. So for the second problem, so first we prove one thing, that is, if A and B is independent, then not A and not B are independent. So the process is like this. So if A and B is independent, then PAB is equal to PA plus P multiply PB. So PA not B, which is exactly PA minus PAB, and this is PA 1 minus PB. This is exactly this one. And we get A out of this and get PA times 1 minus PB. 1 minus PB is PB, not B. So this one is equal to PA times P not B. Okay, so the third one is derived from the second one. So for the third one, P not A not B is equal to P A minus P not A but B. So, and this one is exactly P. And we get the P not A out of this, and we get P not A times 1 minus PB, and 1 minus PB is P not B. So P not A not P is equal to P not A plus P not B. So note that we use this transform. This is not exactly from this, but A and B is the same, so it doesn't matter. So we prove that if A and B are independent, then not A and not B are independent. So given this conclusion, we'll prove the second problem by this one. So we first prove this direction. So given P A given B plus P not A given not B. Then we want to prove that given this, we'll know A and B are independent. Yes. So know that P A given B plus P not A given B. This is exactly 1. So this part they are equal. So this part they are equal. We got the conclusion that PA not A but B. Looking at this equation, we know that no matter what is the result of B, the probability of not A is the same. So this means B has nothing to do with the probability of A or not A. So not A and not B are independent. Yes. So from this conclusion, we can convert this one, and so we got A and B are independent. And this is what we want from this direction. And now we want to prove the other direction is if A and B are independent, then we want to know P A given B plus P not A given not B is 1. So if A and B are independent, then we want to write we want this wait a minute. So if A and B are independent, then A P A B P A P B and so P A given B is P A union B is P B, which is exactly P A B P B or P B. So this is P A times P B over P B. Yes, this is P A. So if they are independent, then P not A and P not B is independent. So P not A not B is equal to P not A times P not B. So using this, we got P not A given not B is equal to P not A not B over P not B. Sorry, P not B, and this is P not A times P not B over P not B, and this is exactly P not A. So this plus this is exactly this plus this. So we got PA plus P not A, and this is exactly 1. So we got if A and B are independent, then this equation is equal to 1. That's it.